Hey, how's it going, everyone? So it's been a while since I've practiced a Leetcode problem, and if you're trying to get into the industry, Leetcode is probably one of those things that you have heard about. It's where you are given a problem, like a programming problem, and you have to kind of solve it. And typically, a lot of companies, at least in the past, they used to give you these problems and watch you solve it live, just so they can kind of gauge your ability to problem solve, your ability to code. Is it useful? I don't really know. If you're a more senior engineer or mid, I don't think doing these type of problems is very useful. Instead, just having a conversation with the developer and try to pick their brain with what have they worked on, what are some hard problems they've solved. It's probably more beneficial than watching them solve a linked list problem. Now, although I personally want to ask these type of things in an interview, I'd rather have someone like just build something live for me. These can demonstrate your knowledge with problem solving in your programming language of choice and just kind of stress your understanding of data structures. So let me know in interviews, are they still asking Leetcode challenges? Like, is this something that they still do? I'd be very curious. Leave a comment below. But let's at least try to solve this. Let's see if I'm actually intelligent anymore, if AI has basically made my brain turn to mush. We're going to read through this problem and then we're going to try to solve it together. So this problem, I just went ahead and picked like the first medium problem I could find. This is called add two numbers. And I'm going to read through it and then we're going to try to solve it. Maybe do a little bit of a eraser or Excalidraw to understand how to solve this. You're given two non-empty linked lists representing two non-negative integers. Okay, so linked lists should just represent numbers, right? The digits are stored in reverse order. Okay, so the number 342 is represented with 243 because it's reversed. And each of their nodes contains a single digit. All right, so that should make sense. Between 0 and 9 should be the value of these nodes. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zeros except for the number 0 itself. So I'm guessing what this means is you won't have a 0 at the end because that wouldn't make sense. All right, here is the problem. So you have 342, you add it to 465, and you should get 807. But you're given these things in reverse order, and I think this helps guide you to a solution. If you've done math the old-fashioned way, where you put the numbers on top of each other, typically you start with the ones digit, then the tens digit, and then the hundreds digit, and then you have like a carryover. So for example, if you do like a 60 plus a 40, you get 100, which means you need to carry over that ones digit to the next location when you're trying to add these things together, right? So this would actually be 400 and something because you carry over that one. And before you jump into solving these problems, again, look at the examples, try to make sure you understand them, see some edge cases. Like here, you're going to get linked lists that just have 0, and you should be able to add them and get the output of 0. Over here, you're getting this example that they showed you in an image. You add these numbers together and you get 708. The output needs to be a list node as well. And here's a more large example of how they add bigger numbers, and you should see that the carryover 1 gets all the way added to the very end. So you get like this large number, was that 1 million or something? So make sure you understand the examples before you jump into the code. And then also read through the constraints. The number of nodes in each linked list is in the range of 1 to 100. This is important. When you're trying to solve these problems, they'll typically give you constraints. And you need to look at the quantity of these constraints because if it's a really large number, you need to think about your big O notation. And sometimes the algorithm you're trying to solve is not going to work with the size of the things that they're giving you. So the number of nodes can be up to 100. So imagine you have a linked list of 100 nodes. This off the bat tells you that you can't just create a giant number and then add them together because you're probably going to go outside the bounds of like the size of an int. Depending on your language, right? Some languages have something called like a big decimal or a big number built into them. I'm going to be using TypeScript, so I don't think they have that built into it out of the box. But it turns out you don't even need that to solve this problem, right? So make sure you look at the constraints and then read through the rest. It's guaranteed that the list represents a number that does not have a leading 0. We kind of already talked about that. So this is the problem we're going to solve out. Let's go ahead and switch over to the coding and see if I can still solve Leetcode problems, all right? Now, when it comes to the linked list, typically you can solve these with like a while loop or probably like some type of recursive call. I'm going to do recursion because I just like it better, but it can sometimes be a little bit more challenging to understand. Now, I would recommend before you jump into solving the problem, if you're doing like an interview over Zoom or some type of screen share, you should probably go over to Eraser or go over to Excalidraw. You need some type of whiteboarding. Like, don't just jump into the code because showing that you know how to actually like discuss the problem and break it down can be something good that you can do during an interview, right? It's not always about solving the problem during the interview. It's about showing someone you know how to communicate and you know how to like plan this out a little bit before you just jump into the code. Okay, so we know when traversing a linked list, you typically have like a starting node. So we have a 2, a 4, and a 3. And if we're trying to solve these, you know, the old-fashioned way with math, you can just basically take these two numbers like this, put them on top of each other. And if we wanted to add them together, we can basically do something like this. And if you paid attention in elementary school when you did math, you typically start with the ones digits. So you're going to add the 5 and the 2, which you'll see here, the 5 and the 2. So I'll add those together and get a 7. And then you go on to the next digit, the 4 and the 6. That gives you 10, which means that you need to take the ones digit of that and you need to carry over a 1 on top of this. So you add in 3 numbers. So 4 plus 3 plus 1, I believe, gives you 8. And so double check that doing this the manual way does match up to the result here, 807. This looks correct. So now that we convinced ourselves about the algorithm, we know how to solve it like with pencil and paper. How do we actually codify this? How do we implement this in code? So you're going to have a node that's going to actually be the very last digit, which is great because that's how the algorithm we did on paper works. We start with the very last digit of your number, the ones digit, and then you need to add them together. So grab the value of the node and then add them. And then if there was a carryover from the previous, you need to add that too. And then if the sum was over 10 or equal to 10, that's when we know we need to carry over something again, so that when we add the next set of digits, we have that carry number. And then we do it again, and then we do it again. Eventually, we're going to hit nulls, right? We're going to get nothing for these values. And then we just basically need to say, okay, well, if a carry came over, let's say this was like 9 plus 9, right? So we have 18, which would be an 8. We need to carry over the 1, but now we're out of nodes, right? Both of these nodes are null. And then we just need to basically return a new node that has a value of 1, or if there were no extra nodes here and there's no carry, then you don't need to actually return anything. So if you're trying to implement this, think about the base case, especially if you're dealing with recursion solutions. Think about the base case first so you know when to break out of the recursive call. And in my opinion, it's keep on traversing these lists until both lists are empty. Okay, so let's go back to the code. I know this probably doesn't truly make sense, but we're going to go back to the code and just try to implement this. So typically when you're dealing with recursion, sometimes you want to have like a helper function. So I'm actually going to just copy this whole function and I'm going to call it helper. And then I'm going to say carry is equal to 0 so that we can actually track if we need to carry over that 1 or not as we kind of like traverse the list nodes. And we're going to try to just use this. So I can simply just say return, and then we're going to pass in list 1, list 2, and then I'm going to pass in 0. Although it is defaulted here, so it might not even make a difference to do that. And now we're going to start implementing the logic inside of this helper function. So the first thing I would probably do is do that base case. When you're doing recursion calls, you want to actually have the base case. So I'm going to say if L1 is equal to, and I do believe this can be null, right? So I'm going to say if it's equal to null and L2 is equal to null, then we basically want to break out. So like for right now, we can say return null, but we want to keep in mind that carry. So for example, let's say this was 8 plus 8. That's going to give us 18. So that's going to carry over that 1 like we talked about. So we need to make sure that we return a new node with the value of 1 in it so that we can actually like point the new thing to that 1 over there. If you imagine this is like the new linked list we're building up, we could just point it to a node that has just 1. So actually I'm going to say if carry is defined, we can go ahead and just return a new list node, and then we're going to put 1 in here. Otherwise, we just return null. Okay, so this is the base case. I think this should work pretty fine. If there's something that we're carrying over, then we should probably return that carry number. If you want to be proper, maybe you should put carry there. Otherwise, we return null because we're done. Like we've hit the end of our linked list. And now let's move on to actually adding this stuff. So we're going to say const sum is equal to L1.value plus L2.value plus the carry that could potentially be passed in from the previous addition that we did. Now, I do think L1 can be null. So this is a little bit more tricky. If L1 is null, then what we need to do is I'm going to do a ternary here. If it's defined, we'll do this. Otherwise, we'll just set it equal to 0. There's a lot of different ways you could probably achieve this type of logic. Put a 0 there. Okay, so basically I'm just falling back. If for some reason we were passed in 2 empty lists, we just basically add 0 and 0 with the carry, and that'll give us our total sum. And then we need to figure out, let's say for example, we sum this together and then we got like 11. So you need to get the new digit of whatever this is. So I'm going to say constant digit is equal to the sum mod 10, and that should give us that ones digit, or whatever, you know, the last number is when you add them together. Regardless if it's greater than or equal to 10 or if it's below 10, it'll still give us the 8 or the 1. But then we also want to say const new carry is equal to, and I'm going to say if the sum is greater than or equal to 10, we're going to set it to 1. Otherwise, we'll set it equal to 0. Okay, so we only care about the carry, which is basically that, you know, the ones, the tens digit, if it's greater than or equal to 10. And then we can kind of use that to pass into the recursive function. Okay, so now what we want to do is we want to make a new node, because we just added 5 and 2. If you were to kind of read through the code and walk it through with this example, we're going to start with L1 being 2, L2 being 5. You add them together, you get 7. Okay. Carry will be 0. So you'll get digit is 7, new carry is 0. And I can just go ahead and say const node is equal to new list node. We're going to pass it the new digit. And then we're going to say node.next is equal to. And here's the cool part. This is where we do the recursion. So I'm going to go ahead and just call that add two numbers helper. I'm going to say L1.next, L2.next, and then I'm going to say new carry. Like this. And then we could just go ahead and return the current node. Now keep in mind L1 could be null. So I think we actually want to do like a question mark there so that we can actually have it not crash. Otherwise this will probably crash because it's going to say null.next, which is going to be defined. So let's actually step through this code with this example problem and make sure that it seems like it's right, and then we'll run the test cases to see if we actually got it right or if we're missing anything. So again, we're starting with 2 and 5. We add them together, we get 7. So digit will be 7, new carry will be 0. We make a new node of 7. And then we set the node of next equal to, and then we recursively call this again, which we're going to pass 4, and then L2 would be 6. So this is 4, this is 6, and then we do it again. So are we at the base case? No. So we're going to go ahead and add 4 and 6, which gives us 10. We're going to mod it by 10, which gives us 0. And then we're going to check to see if we have a new carry of 1 or not, which we do. So then we'll make the new list node digit, which will be 0. And then we say node.next is equal to the recursive call of the next of L1, which would be 3. And then the next of L2, which would be 4. And then carry would be 1 at this point. Okay, so 3, 4, 1. And then we call it again, right? So we're going to say L1 is defined, L2 is defined. So we're going to add them together. So 4 plus 3 gives you 7, plus the carry gives you 8. Same idea here. We're going to make a new node with 8 as the value. And then we say node.next is equal to the recursion again. Now this is where we actually start getting to the nulls, right? So L1 of next is going to be null. L2 of next will be null. So we should get over to this right here where they're both null. So there we're going to check if there's a carry bit. There's not. So we go ahead and just return a new, we just go ahead and return null, right? So this is going to basically point this node, its next node, to null. So I think that should be good. I mean, what you should also probably do is make up your own test cases. When you're trying to do these interviews, it's nice when you can show an interviewer that you can think outside the box and like test more examples than what they gave you. So one good example we could do is, let's just pretend like we're doing 9, and then this could be 9, and then this could just be 9 as well. So we're going to have two lists, a 9, 9, and then this one will just point to null, and we'll try to add those together. So same idea. We're going to step through this one more time and make sure we can do it and test it manually before you try to run the test cases. So keep that in mind. This is L1, and then this is going to be L2. So we're going to start with 9 for L1, and then L2 will be 9. We're going to sum them together, which gives us 18, which means the new node will be 8. So in fact, we should probably make sure we have the correct output ready. So this should be 8, which will carry over 1. And then 9 plus 1 gives you 0. And then we should have a 1 over here. Okay, so this should be the final solution when we add these things together, if I did my math correctly. And of course, type this into a calculator. So we should get 801 for our list, 801. Okay, so the math is correct. I want to make sure my test case seems good. Let's go back. In this case, the new carry should be 1. And currently we have a digit of 8, like I talked about. So we're going to go ahead and just do the recursive call. And we're going to have L1 will be 9. L2 is going to be null, right? And then carry will be 1. So this base case won't run. We're going to say 9 plus 1 gives us 10. Mod it for the digit gives us 0. New carry will be 1. We make a new node of 0. We set that next to the recursive call again. And then we should again get L1 doesn't have a next, right? L1 at this point is null. And then L2 is also null. And so we're going to move on again and do one more recursive call. That's going to hit this. Carry is 1, so we make a new list node that has a 1 in it. We return that, and we basically just finish chaining this whole list together. And I think that should be good. Like this algorithm, I feel like I implemented it correctly. Now, before we submit this, I think go down here and actually just add in a test case. So for example, let's probably do the 9, 9. And then also just do the 9 here. And click the play button. That should run your code against those test cases. And you can at least try to figure out, like, is your stuff working or not? And you can click test results. Okay, it looks like it is failing on this one with a maximum call stack size exceeded. So we are doing an infinite recursion. So we'll have to step through and try to figure out what we're doing wrong here. Now, my first hunch is this, the question mark. Maybe this actually could return undefined. So like, maybe I just need to say if not, and if not. Let me try running that and just see if that's kind of going to fix our issue. And that's working now. Yeah, so I think that was a little issue with my approach where when you do this nullish coalesce here, is that what it's called? I think it was just a small issue with my implementation where like I added this, which could potentially have this return undefined. So if we wanted to make this a little bit more proper, I think actually what I would do is probably say if L1 is defined, we'll say L1 next. Otherwise, we'll say null. It's a little bit more verbose, but at least we're making sure that our values will be what they should always, be expected to be. Let me try this. I'm going to try to run my test cases again with that change and probably indent these so we can actually like view this a little bit better. Make sure I type in L1 there, run this again. Okay, so all of our test cases pass, and even the new one that we added in, again, you should probably add in a couple more test cases to help you debug this. And I'm not sure if there's a way to actually have like a debugger and step through this code. That's the one problem with these like Leetcode editors is that like you can't really step through your code unless I guess you upgrade to premium. You can use a debugger, but we're not going to do that. So, all right, so let's just submit this and see if this is going to make all the test cases pass. All right, looks like we're good. We have a solution that passes this, and it's cool to check your runtime. Right now, mine's running pretty fast. It beats 92% of all submissions, and then the memory is also pretty good. It beats 99% of the submissions. So if you didn't get it right, obviously go to the solutions that other people have submitted and type in like something like JavaScript recursion to see other people's approaches. That, so here's like an example of how they did the recursion as well. Again, it looks different than mine, but it basically solves it the same way, right? So I think this is a pretty good problem. These type of things you should know how to solve. Now, granted, during an interview, it's going to be more challenging because when someone's like breathing down your shoulder, it's always intimidating. But at least doing some of the things I showed you during an interview, if you are asked to do like a Leetcode problem or some type of like coding challenge, is read everything. In every sentence you read, make sure you can like re-explain it to yourself and convince yourself you know what it's talking about. Look at the examples. Look at the additional examples they gave you. Look at the constraints and make sure you think about all edge cases. Also, be sure you add your own custom test cases. That really shows to an interviewer that you're thinking more outside the box of like how to make this proper. Think about performance. Maybe in some cases you can't just add 100 digits together because that's going to change the way your algorithm will work. Some people might have been trying to like add a bunch of these things to a string, and then they could do like a parse int on the string, which obviously is going to crash, right? So the constraints are very important. They can really dictate your solution. So you need to make sure you understand the constraints. And like always, if you can draw this stuff out on a diagram to make sure that you understand it, and also try to convince the interviewer that you understand it, although sometimes it feels like you don't understand it, you're just drawing circles, at least it looks like you're, putting some thought process into it, and then you can get to a solution. All right, so that is about it. Be sure to let me know in the comments if you enjoyed me doing this type of problem for you all. I do think it's good to practice these once in a while, although they're completely like unrelated to our day job. Like I don't think I've ever used a linked list at all in my entire career of like 11, 12 years. But it's nice to understand these data structures and be able to explain them and understand their use cases. And solving these type of things shouldn't be too hard if you feel like you're pretty good at programming, right? This problem was not too challenging. It is a medium problem, but knowing how to sit down and solve this within 30 minutes to an hour, it shouldn't be too hard for you. And if it is, you should probably practice these, because again, understanding the problem, how to break it down is part one of your solution. And then solution part two is translating it into code. And that's also something that's challenging for a lot of people when they're starting off. So make sure you do practice these things. I think they are beneficial to your overall coding career and knowledge, but they're more like supplementary learning instead of like this is the core thing you're going to be doing when you get hired. All right, hope you guys enjoyed. Have a good day and happy coding.